Hi everyone, I'm Brittany Kokinis and I'm from the University of Wisconsin-Madison in the Department of Animal and Dairy Sciences. Today I'm going to share with you some new techniques our lab is working on to monitor the regression of osteochondrotic lesions in pigs. So today we're going to discuss what osteochondrosis is and why we're interested in it and what impacts it has on the swine industry, as well as current studies that our lab is working on and future directions we hope to get to in the next couple of years. In addition, we use non-invasive assessment to be able to track the progression or regression of these lesions in our pigs through the use of CT and MRI scans. We also quantify these lesions in a software so we can analyze them for future reference. So what is osteochondrosis and why we're interested in it? Osteochondrosis is the failure to convert growth cartilage into mineralized bone during your growing period. So in your long bones, for instance, like your femur or your humerus, you have growth plates. And within these growth plates, you can see it should be this fairly thin layer of cartilage, pretty consistent until we get to this lesion right here, where we see this retained cartilage and unmineralized bone. That is what we consider an osteochondrotic lesion, as well as this can occur on the articular surfaces. So this has significant lameness issues within the swine industry, where obviously, as you can see, it's this softer portion on the bone itself. So when the pig is walking, they get the mechanical load is pushing up against a soft area, which could be painful. So this has significant financial issues for the producers, where if they have severe lameness issues in their herds due to osteochondrosis, the pigs themselves may or may not be able to get up on their own to get to the feed or water, so they might not grow very well as potentially not being able to walk onto the trailer to be able to be sent to market when they reach market weight, because there's more body weight pushing on these regions of interest. So our lab has developed a model to be able to induce these osteochondrotic lesions in pigs, through which we're able to induce different dietary interventions to reduce these incidences of lesions that we observe in our herd. In addition, we hope to do some more longitudinal studies where we observe, we take the same animal and we observe the lesion progression and regression over time at multiple time points throughout their entire growing period, instead of looking at what we are currently doing with cross-sectional studies, where we're looking at one subset of pigs at one time point and then another subset of pigs at a later time point and comparing the two. So our osteochondrotic model was developed by our lab quite a few years ago, where we induced these humpback pigs, and osteochondrosis has a significant impact on this because, like I mentioned, where you get this retained cartilage, that occurs in the spinal column as well, not just our long bones, but it also happens in our long bones, as you can see with this growth plate. So our lab is currently working on different dietary interventions through utilizing this model, inducing different dietary treatments to be able to see which treatments regress these lesions at a quicker, rapid way in a more cost-effective manner. So our future goals, like I mentioned, are to track the progression of lesions within the same animal over time. So some previous studies we did, preliminary work, we were able to scan whole market weight 160-pound pigs in a typical CT or MRI scanner that you would go to the doctor if you needed an MRI or CT. And through that, we were able to put the scans into our computer software to reconstruct the three-dimensional whole body image. More work needs to be done with this area in our lab. So when I talk about these lesions and CT scans, mineralized bone in CT shows up in a lighter color. So then we're able to see the growth plate here where it's darker. And then if we look over at the MRI, it's a little different, where we get a little bit more detail of soft tissue with cartilage here and mineralized bone being darker, excuse me. So with our computing software we use, we're able to reconstruct three-dimensional images to be able to visualize and quantify the number, volume, surface area, location, as well as density of these lesions, through which we can use this masking tool where we are able to decipher out where it's mineralized and what is not mineralized, where it's that retained cartilage, which is that lesion. So in a previous cross-sectional study our lab has conducted, we were able to compare pigs, a subset of pigs at 12 weeks of age, as well as a subset of pigs at 24 weeks of age. And we were able to determine differences between the number of lesions, the volume, and the surface area at 2 different time points. In addition, our lab has worked with a tool to be able to, the same software, to be able to look at the specific locations that these lesions occur in and confirm that the locations we're finding within the software relates to the actual bone that we scanned. So we're able to go in and find the coordinates within the software and go in and cut that bone at that location and find the lesion within the actual bone. Lastly, we are able to determine the density of the bone within a lesion. So as you can see, this is an MRI scan where we thresholded this lesion, so we can observe that it's a different density than this more mineralized bone in here, but it's not quite necessarily cartilage. It's somewhere in between. So we're able to set these different regions of interest, such as 1, 2, 3, and 4, 5, around the lesion itself and within it. And we're able to set different densities to be able to measure the bone underneath. And this is just a 3D reconstruction of this particular lesion. So ultimately, our lab is working on 3-dimensional reconstructions of CT and MRI images to allow for detailed progression or detailed non-invasive imaging analysis of regions of interest during the progression or regression of osteochondrotic lesions in pigs, through which we hope to be able to induce or produce different dietary treatments that would be able to regress these lesions, to be able to contribute to the nutritional needs of the animal, as well as being able to help producers mitigate the observations they see within their herd to prevent financial losses, as well as preventing lameness within their herds. So thank you for listening, and if you have any questions or just want to reach out and say hi, I am Brittany Kokinis, as I mentioned, and you can reach me at this email, or you can reach Dr. Tom Crenshaw at his email. And thank you for listening, and have a wonderful day.